Now that we're talking about solving radical equations, we know that radicals can also be written as fractional exponents. So we should talk about equations written with fractional exponents as well. We'll start with this example here, 2 times x to the 2/3 plus 1 equals 9. And of course, since radicals and fractional exponents are kind of the same thing, we're going to have a lot of the same principles that we're going to apply. Like first, we're just going to sort of isolate the part with the radical or with the fractional exponent involved here. So we'll have 2x to the 2/3 equals 8. And then we can divide both sides by 2, and we get x to the 2/3 equals 4. So just to compare this to what we were doing with simple radical equations, when we had something like this, root of x minus 3, well, we would square both sides, because squaring that left side would get rid of the radical. Let's look at what that would look like in the form of a fractional exponent. If we have an exponent of 1/2, what we really want to do is cancel that. We want to get rid of that. What exponent would cancel with 1/2? Well, remember, if we put an exponent here, exponent rules are we would multiply these. And so what would cancel that 1/2 is multiplying it by the reciprocal. So that's the exponent. We could just write 2, but I'm writing 2/1 just to sort of show that it's the reciprocal. That if we use that reciprocal exponent, then it's going to cancel out the exponent that we started with. Pardon me. So let's apply that same logic over here on our original question. We have an exponent of 2/3. What's going to cancel that? Well, the reciprocal exponent, 3/2. So those cancel. Again, remember that would be multiplying. So that would just be x, or x to the first. And we end up with x equals 4 to the 3/2. And we know how to do that. The 2 in the denominator means the square root of 4, that's 2. And then that cubed is 8. Anytime that we have, whether it's a radical equation or an equation with fractional exponents, same thing, we know that we always need to check for extraneous answers. And this one's going to be fine, but let's do it just to make sure that we're in that habit. So we've got 2 times 8 to the 2/3 plus 1 should equal 9. So that's 2. Okay. Cube root of 8 is 2. That squared is 4. And we can see, yeah, that does in fact work out. So x equals 8 is a legitimate answer. So let's apply these principles to a little bit more complicated question, although not too crazy. We've got 3x plus 1, quantity all to the 3/2 power, equals 64. So the good news here is that the fractional exponent part is already isolated. There's nothing added here or multiplied there. So we can immediately work on canceling out that exponent. This is 3/2. The exponent that's going to cancel that out is 2/3. And we'll do the same thing on both sides. All right, that cancels out. We get 3x plus 1 equals 64 to the 2/3. So the cube root of 64 is 4. That squared is 16. Subtract 1 from both. And divide by 3. And again, this one should be fine, but we'll check, because anytime we have this type of equation, we check for extraneous answers just as a habit every time. So we've got 3 times 5 plus 1 to the 3/2 equals 64. Okay, 15, 16 to the 3/2 equals 64. So square root of 16 is 4. 4 cubed is 64. So that works, and x equals 5 is a real answer. Great, let's do one more.